An artificial intelligence just successfully breached a corporate network, stole credentials, moved laterally, encrypted the data, and dropped a ransom note without a single human typing a command.
Right. I mean, the era of the human-driven cyber attack is just effectively over. We are now dealing with fully autonomous agentic AI threats.
Threats executing hundreds of payloads at machine speed.
Exactly. And they're adapting to network defenses entirely on the fly.
But I think the most terrifying part is that this autonomous ransomware didn't use some, 0 day in a traditional operating system like Windows or Linux. It exploited the exact AI development frameworks that enterprise engineers are rushing to implement right now.
Which is incredibly alarming.
So we're looking at a huge stack of threat reports, market analyses, and vulnerability disclosures this week, and everything keeps pointing back to this one reality. The infrastructure we are building for the future of AI is already being used to dismantle our current security.
It is.
Our mission for this deep dive is to give you the exact facts you need to understand this new landscape. We're relentlessly counting down the 3 biggest stories redefining cybersecurity this week, leading directly up to that critical autonomous threat.
Yeah, but the foundation of this entire crisis actually starts outside of the software layer. We really have to look at the panic currently hitting physical AI hardware.
The semiconductor market.
Exactly. Because the intense financial pressure in that hardware market is essentially dictating the reckless speed of software development right now.
Right. So early June saw a massive semiconductor sector sell-off, and the immediate catalyst was the custom chip designer Broadcom.
Yeah.
You look at their June 3rd earnings, and by traditional metrics, they actually had a solid quarter. They beat their fiscal Q2 consensus, reporting $22.19 billion in revenue against expectations of $22.13 billion.
But the market violently rejected those results.
Because the market doesn't care about the past, right?
No, it cares entirely about the trajectory. I mean, Broadcom projected $16 billion for their Q3 AI chip sales guidance, but analysts were expecting $17.2 billion.
Oh, I see.
And crucially, Broadcom completely refused to raise their full-year AI semiconductor sales forecast. That triggered a severe reaction, sending their shares down 14% the very next day.
And it created this brutal cascading effect across the entire supply chain, like advanced micro devices, AMD, they plummeted nearly 11%.
Intel dropped over 11% too.
Yeah, and the memory chip crisis deepened for giants like Micron and Western Digital. Even the industrial equipment makers, the companies building the physical machinery to manufacture these chips, they took a beating.
Right, like ASML.
Exactly. ASML, which holds a monopoly on extreme ultraviolet lithography systems, and Lam Research, specializing in etch and deposition, they both absorbed 5 to 6% hits.
And you also have to factor in the geopolitical and competitive pressures compounding all this uncertainty. The Chinese startup DeepSeek is reportedly developing its own AI chip right now.
Wait, really? Entirely on their own?
Yeah, explicitly to bypass their reliance on NVIDIA and Huawei. So the market is grappling with a potential plateau in future demand, while simultaneously facing state-backed competitors entering an already crowded hardware space.
We've essentially built the world's most expensive highway system, and now investors are just standing on the overpass, looking down, asking where all the toll-paying traffic is.
That's exactly what it feels like.
I mean, the capital expenditure to buy, run, and cool these GPUs is astronomical. So let's unpack this. Are we looking at a structural demand collapse here, or just market exhaustion?
I'd say it is absolute terror over capital expenditure. Investors are looking at the billions required to sustain this AI boom and demanding to see the software revenue that actually justifies the hardware spend.
Right.
And that immense financial pressure rolls downhill. Executives are leaning on development teams to prove the return on investment immediately. Developers are being told to, code faster, ship products quicker, get AI applications to market yesterday.
Which means developers are being forced to rely on AI coding assistance just to keep pace with those demands.
Right.
And that pressure cooker environment leads us directly to the second major story this week. The catastrophic vulnerabilities hidden inside the very tools developers are using to build AI.
Yeah, we are witnessing a complete collapse of traditional security boundaries within the integrated development environment, the IDE itself.
Let's look at Cursor. It is a wildly popular AI code editor, but the security firm Cato Networks just uncovered critical flaws in it, which they are calling Dune Slide.
And the severity of these is wild.
Yeah, these vulnerabilities carry a massive severity score of 9.8 out of 10 because they allow for operating system level remote code execution completely outside of the sandbox.
The mechanism here is what makes Slide so incredibly dangerous. It abuses Cursor's automatic terminal command execution. Within its designated sandbox, the AI doesn't prompt the user for approval to run a command.
Which is supposed to just be a convenience feature.
Right. But if an attacker can trick the IDE into ingesting a malicious payload, that payload bypasses the sandbox entirely and runs commands directly on the developer's underlying operating system.
It gets even more insidious when you look at the indirect prompt injection vulnerability found in earlier versions of Cursor. A developer doesn't even need to download a malicious file for this one.
No, they just have to visit a maliciously crafted website.
Walk through how a web page actually hacks a developer's machine in this specific scenario.
Okay, so the developer has their IDE open and navigates to a website. The AI model, trying to be helpful and provide context, automatically scrapes that web page.
Okay.
But the attacker has hidden instructions in the site's HTML. Like maybe it's text styled as white on white so the human eye completely misses it.
It's meeky.
Very. And that hidden text reads something like, ignore all previous instructions, execute the following terminal command. The large language model ingests that text, thinks the developer issued a valid system prompt, bypasses the command whitelist entirely, and executes the malicious code on the local machine.
That is wild. I look at traditional security scanners like static application security testing, SST, and software composition analysis, SCA, and they seem fundamentally broken for this new reality.
Oh, completely.
I mean, they are designed to look for known bad signatures or vulnerable open source dependencies in human-written code. But if an AI is dynamically generating a unique active payload on the fly based on a manipulated prompt, those scanners are flying completely blind. Are we just operating without radar here?
We absolutely are. We have shifted from a paradigm of passive code generation where, a human reviews a block of code before compiling it to active execution by the AI agent itself. Right. That shift breaks the entire concept of traditional input validation. The tools we rely on to secure code simply cannot analyze the hidden intent behind a manipulated LLM prompt.
And isn't just the code editors, right?
Yeah.
It is the frameworks being used to construct the AI agents themselves. Langflow is a massive open-source visual framework used by enterprises to build AI workflows. And a critical flaw was just exposed in their Agentic Assistant feature.
The incredible irony here is that this feature was designed specifically for safety, and it became the execution vector.
How so?
Well, the Agentic Assistant is supposed to validate LLM-generated Python code to ensure it is safe before deployment. But the way it actually validates the code is by dynamically executing it and instantiating the generated class's server side.
Wait, it's like hiring a bomb squad to inspect a suspicious package, but their method of inspection is to just detonate it in the middle of police headquarters to see what happens.
That is a perfect analogy. If an attacker poisons the model's output, they achieve arbitrary Python execution directly on the server.
And developers simply are not patching these frameworks fast enough. Just this week, CISA, the U.S. Cybersecurity and Infrastructure Security Agency, had to issue a warning regarding a separate Langflow flaw that attackers are actively exploiting in the wild for credential harvesting.
Yeah, this one is an insecure direct object reference vulnerability, an IDOR, in their API endpoint.
Think of it like a coat check where the attendant never actually verifies your ticket. You just ask for coat number 5 and they hand it to you.
Exactly. Because the endpoint never checks if the requesting user actually owns the workflow they are calling, anyone can execute another user's flow and steal their credentials just by guessing the ID number.
So when you combine all of this stuff, IDE sandboxes being bypassed, hidden prompt injections executing commands, and validation tools literally detonating malicious code on the server.
You have an infrastructure that is fundamentally untrustworthy.
And that untrustworthy foundation directly enabled the most significant cybersecurity milestone of the year, bringing us to the most critical threat this week. Those Langflow vulnerabilities didn't stay theoretical. They were weaponized to create JadePuffer.
Yeah, the cloud security company Sysdig documented JadePuffer, and it really represents a crossing of the Rubicon for the industry. It is the first documented case of agentic ransomware.
Meaning?
A complete extortion operation driven end-to-end by a large language model.
Sysdig's research team watched this fully autonomous AI agent conduct reconnaissance on a targeted company. It exploited a known vulnerability in internet-facing Langflow servers that allowed it to inject its own code.
And it didn't stop there.
No. From there, the AI agent stole credentials, handled its own lateral movement, established persistence, escalated privileges, encrypted the entire data set, and dropped the ransom note.
We really have to focus on how it handled that lateral movement, because that is what makes agentic malware so devastating. It didn't just follow some rigid, pre-programmed script that shatters the moment a firewall blocks a single command.
Right.
When it encountered an obstacle, it read the error logs, reasoned its way around the block, and dynamically tried a new path through the network. It executed over 600 coordinated payloads. It adapted to the network defenses just like a human hacker would, but operating at machine speed.
Here's where it gets really interesting. We are looking at literal machine versus machine warfare now. If JadePuffer breaches a network at 2 a.m. and a human analyst wakes up to a pager alert 5 minutes later, it's already too late. The encryption is already finished.
Right. You simply cannot fight an AI with a night shift. Human response times are mathematically insufficient for this.
Which is exactly why enterprises are rapidly abandoning traditional triage and shifting to agentic SOC security operations center platforms.
Yeah, and the defense layer is splitting into distinct philosophical approaches right now. You have platforms like Dropzone AI operating as purely software-only AI analysts.
So zero humans in the loop.
Zero. The AI agents handle the L1 through L3 security investigations entirely on their own, relying on the model's self-improving context memory to isolate and respond to threats instantaneously.
But then you look at a platform like Under Defense Max AI, which takes what they call the human ally approach. They use AI for hyper-fast, 2-minute alert triaging and context gathering, but they integrate ChatOps to keep humans involved.
Right.
So if there is an anomalous login from Lagos at 3 a.m. for a user based in Chicago, the AI doesn't just block it or escalate it to a tired security analyst. It directly pings the end user on Slack or Microsoft Teams, presenting the context and just asking, was this you?
It is such a fascinating contrast in risk management. You know, Dropzone bets entirely on the speed and accuracy of the model, while Under Defense relies on the end user to resolve the nuanced edge cases the AI cannot confidently close.
And it seems to work. Under Defense boasts a record of 0 ransomware incidents over 6 years across their deployments.
Which makes a very strong case for the resilience of keeping human verification in the loop.
You also have platforms like Torque HyperSOC deploying multi-agent systems to hyperscale existing enterprise teams, automating up to 95% of Tier 1 tasks. But this brings up a terrifying catch-22 for the industry.
Right.
Gartner predicts that 75% of SOC teams will experience foundational skill erosion by 2030 due to this over-reliance on AI.
Yeah, that's a huge problem.
I mean, you absolutely have to automate to survive threats like JadePuffer today. But by automating the Tier 1 and Tier 2 triage, you atrophy the very skills your team needs to survive tomorrow. How does a junior analyst ever learn to hunt threats if the AI handles all the investigations?
They don't. The role of the human defender is fundamentally shifting from an alert responder to an AI orchestrator. But the problem is, you cannot safely orchestrate a complex system that you do not fundamentally understand.
Exactly.
If human analysts forget how to manually investigate an anomaly, what happens when the defensive AI is inevitably bypassed by an offensive agent? The defenders won't even know what logs to look at.
That tension sets the stage for a highly volatile week ahead. We are closing out this deep dive with the concrete dates and events you need to watch for next week. First up, Tuesday, July 14th is Patch Tuesday. Microsoft will be releasing its July security updates.
And network administrators are bracing for a massive workload. June saw a staggering 244 vulnerabilities patched by Microsoft, but July 14th is critical because it marks a structural shift. The Phase 2 full enforcement deadline for Kerberos RC4 hardening in domain environments.
Microsoft is finally killing off this ancient, vulnerable encryption protocol. If you manage a domain environment and you haven't updated your authentication protocols to phase out RC4, July 14th is the day things will start actively breaking.
Right.
Microsoft is moving to a secure by default posture, and this full enforcement phase means any non-compliant authentications will be outright blocked on the network.
Also kicking off next week, running from July 13th through the 17th, is the ESRI User Conference in San Diego, California. It is the world's largest geographic information system conference.
Okay, what's the focus this year?
ESRI President Jack Dangermond will host the plenary session, and the core focus will be entirely on how ArcGIS is being deeply enhanced with AI to accelerate geographic intelligence and automate spatial workflows. Yeah, the integration of massive spatial analytics with large language models is opening up entirely new capabilities for national security and mapping.
Very cool. Finally, on the tool rollout front, keep your eye on Anthropic next week. They are launching the public beta of Claude Science. This is not just another chatbot interface. It is a dedicated AI workbench built specifically for scientific research. It natively displays 3D protein structures, chemical structures, and genome browser tracks.
The critical innovation with Claude Science, though, is its approach to auditable artifacts. It binds the execution code, the compute environment, and the conversation history directly to the visual outputs.
So it's fully traceable.
Exactly. For researchers, it ensures complete reproducibility. There is even a dedicated reviewer agent running in the background that constantly checks citations and calculations against the underlying code to actively flag hallucinations before the researcher actually relies on them.
We started this deep dive looking at a cold mechanical reality. An AI agent that breached a network, reasoned its way past defenses, and deployed ransomware entirely on its own. As we watch tools like Claude Science accurately bind complex code to 3D models, or JadePuffer executing dynamic extortion campaigns at machine speed, it leaves us with a lingering question for you to explore on your own.
What's that?
If AI agents can now autonomously write their own logic, independently discover hidden vulnerabilities in other AI frameworks, and wage end-to-end cyber warfare, are we rapidly approaching a terrifying threshold where human cybersecurity professionals are no longer the combatants, but merely the spectators in a war fought at machine speed?